Today we are going to solve some numerical based on combination of capacitors. First question is like this. In this question, if you give a look, you will see that these three capacitors, they are in series. So we can redraw this diagram like this, in which 4, 2 and 4 microfarad they have shown in series. Similarly, these two, they are also in series. So these two, they have shown in this diagram in series combination. Now we know the formula for the resultant of the three capacitors in series. So 4, 2 and 4, if you use the formula of the series combination, we can get the result equal to 1 microfarad. Similarly, for these two, if we use the formula for the series combination, we get the result 4 by 3 microfarad. So means this diagram reduces to this, and then this diagram reduces to this. Again here we see that these two, they are in parallel. So we can use the formula for the parallel combination, and in place of these two we can draw only one capacitor. And as a result, now finally we have only the two capacitors which are in series, and then we can use the series formula and get the final result. Now come to the second question. In this question, these two, they are in parallel to each other. Now we know that the parallel combination resultant C is equal to C1 plus C2. So in place we can redraw this diagram like this. So these two, they have shown in parallel combination. These two, they are in parallel, so they have shown here in the parallel combination. So resultant of these two, they have shown parallel, and the result is 2 microfarad. Here the resultant of these two, they have redrawn like parallel combination, and we get the resultant as 8. So in place of these two, it is reduced to this one. In place of this, it is reduced to this. So the whole diagram, this is reduced to this one, and here again by calculating or using the formula, it reduces to in this diagram. Here it is clear that these two, they are in series, and these are also in series. So using the series formula, we can reduce the diagram into this diagram, and finally we can get the result, which is equal to 5 microfarad. Now come to the third question. In first look, this question looks very complicated as many capacitors are shown in this diagram. But if you look carefully, then you will see that these two, they are in parallel combination. In parallel combination, the resultant C is equal to C1 plus C2. So in place of these two, you can write 120 plus 80, that is 200. So these two, they are reduced to 200. Then again, if you look on this, then here 200 and 300, these two capacitors, they are in series. So their resultant will be 200 into 300 upon 200 plus 300, that is 500. So if you simplify this, then you will get 4 3s are 120. So here it has 120 microfarad. So in place of these two, 200 and 300, we can write 120 microfarad. Similarly, in place of 80 and 120 microfarad, you can write the resultant, which is 40, and in between that is 40. So these three are in parallel to each other. So it means we can say that in place of this one, we can redraw diagram like this. Again 800 is outside, so 800 is outside. In place of these two, they are in series, so we can write only one combination, that is equal to 50 microfarad. So now we can say that this diagram is reduced to this, where we have written the equivalent resistance. Now this can further reduce to this one, because we know the formula for the parallel combination. So in place of these three, that is 120, 140 and 40, we can use the parallel combination. In the result will be the sum of all these three, which will equal to 300. So in place of this we have written 300, this is 200, so 200 as it is. In place of this is 300, and outside that is 600, so which is written 600. So in place of all these there are only now three capacitors, 200, 300 and 600. So which are in series combination. In series combination you know the result, so which will reduce to only one capacitor, which is 100. So now we will have only the four capacitor, that is initially 300, 100, 50 and 100. In this again these 250, they are in parallel combination, so the result will be 150. So now in this step they have reduced only to 3 which are in series and series combination. So finally we will reach to the result, which is 50 microfarad. Similarly, you can solve this problem. Now this is a little bit different problem, because here in this problem it is a series in which is going up to the infinity. So little bit different technique we will use here. So let us consider that net capacitance of the infinite ladder network of the capacitance we see. Infinite capacitance we see. Since the entire network can be formed by successfully adding a small unit of two capacitor, that is either by this two or by this two, means in this diagram if you look carefully, so either this series is formed by adding these two, or it is formed by either these two. So we can say that this infinite network, the entire network, can be formed by successfully adding a small unit of two capacitors from left to the right. The net capacitance of the network in excluding one unit will also be C, because it is infinite series. Infinite series means if you reduce one unit, then there will not be any much effect on the resultant. So we can say if you reduce one unit, then even the resultant capacitance will be equal to C. So we can redraw the entire for the simplification, that is equal to between A and B, that is 1 unit plus up. In this case you can redraw it like this, that is the whole unit is drawn like this, 1 unit, which is 1 unit, and it is connected to C. So not 1 unit, means this is the 1 unit, and the which is connected to the resultant capacitance of the entire network, which is equal to C. Means when you are adding 1 unit to C, then it will not make any effect. Now we can reduce it. Here it is clear that 1 and C, these two, they are connected in series. So resultant is C upon C plus 1, which is connected to 1 microfarad. And if you reduce the result of these two, then this will be equal to 1 plus C upon C plus 1. But the capacitance between A and B, the capacitance between A and B is equal to C. So we can write this is equal to C. So we can write 1 plus C upon C plus 1 is equal to C, and by simply using the mathematics, using the knowledge of the mathematics, if we simplify this, we will get the final result. C is equal to 1 plus minus root 5 upon 2. This is very important example regarding the CBSE board. Now here this is example number 4 and example number 5. Now this can be reduced in this way. Now here, if we redraw this, we have to find the resultant capacitance between A and B. Between A and B. So we can redraw it like this, where from here to here. If you see carefully, then its diagram is this. Now here we are going to use a very important result, that is a Wheatstone bridge result, which we will study in the next chapter, but we will use it here. Since 5 and 20, these are the 5 and 20, the ratio of 5 upon 20 is equal to 10 upon 20, which is same. So 10 upon 40, that is 5 upon 20, that is 1 by 4, and 10 upon 40, that is 1 by 4. Since the ratio of the two arms AC and BC is equal to the ratio of AD and BD, so this is known as the Wheatstone, which is in the balanced condition. When it is in the balanced condition, then there will be no current in the arm DC. That is, in DC there will be the no current. So we can exclude this capacitor. So the resultant of this capacitor, we will have only 4 capacitors, 5, 20, 10 and 40. And from this figure it is clear that 5 and 40 they are in series, 10 and 40 they are in series. So if we use the series formula, we get 4 and 8, which are now in parallel to each other, and their resultant will be only one capacitor, which is equal to 12 microfarad. So in this way we can solve the different types of problem. Hope you have understood, and you will be now able to solve the different questions easily. Thank you.